So as we saw on Friday, we're no longer talking about proportions. We're going to talk about means, averages, quantitative data. You may want to go ahead and grab a pink t-test table, because now instead of the z-score, we want to look at the t-score. Because it may not always be prudent or feasible to have a sample size greater than 30. A lot of times you're going to be less than that. And that's where the power of the t-test comes in. First, with the t values, or the means, we will look at the confidence interval. So with your t-table, notice there's lots of different kinds of t-tables. They're going to have the same value, but how they're organized is going to be a little bit different. I have put several varieties in today's folder. So there's a t-table that has more values than here. Notice how here you get to 30 and then it jumps to 40, 50, 60, 80, 100. Oops.
Where's that?
I have no idea. This table, I believe, goes all the way to 100. Yeah. This one goes all the way to 100, and then you see 120, 140, 160. So this table has a lot more values. But notice it's based on your t values up here, your percentages. There's another table in there, confidence interval, that just like in here, it translates those values, your p-score, into confidence interval. So notice if I'm talking about a one-tailed test, a 0.1 will be at 80% confidence level. Same thing here. Now, unfortunately, this front page doesn't have the confidence intervals. So you got to go look at the back. It's down here on the bottom. A 99.9% confidence interval is equivalent to a one-tailed t-score alpha level of 0.0005. A two-tailed test, so this is a confidence interval really regards to is a two-tailed test. 0.2 is 8% or 80%, 0.1 90%, 0.05 95%. So it's taking that value, that alpha value, and subtract 1. This one actually sets up with the confidence interval, but I think its limitation, it also stops at 30 and then goes 40 to 60. So, yeah. This is there if you're lucky enough to have your DF, which, oops, wrong class, your degrees of freedom in this table. 9 times out of 10 you will, so don't have to worry about that too much. There we go. So, what is the critical value for a 90% confidence interval in degrees of freedom of 5? Critical value is that, score here, or alpha score. So I want to know where can I have 90% confidence where my areas of reject from the null will be here, outside. I want to decrease this as much as possible. Well, where is my 90%? Right here. I want to see degrees of freedom, so that's what this DF means, of 5, and where do I see 90%? 90% degrees of freedom of 5 right here at 2.015. That is my critical value. So if I was talking about a one-tier test, my critical value would be probably right around here of alpha 2.05, and if it was a two-tier, it would be a positive and negative value. What is the critical value for a 98% confidence interval with degrees of freedom of 12 from this table? %98 confidence level, degrees of freedom is 12. What do you see?
2.681.
Yeah, 98%, 12, 2.681. So that's how you're going to find the critical values. You're going to use the table. that would be more accurate than using the calculator. So we're going to use a table for these critical values. Now what about confidence interval? In 2004, a team of researchers published a study of contaminants in farm salmon. Fish from many sources were analyzed for 14 organic contaminants. The study expressed concerns about the level of contaminants found. One of those was the insecticide Murex, which had been shown to be carcinogenic and is suspected to be toxic to the liver, kidneys, and the endocrine system. One farm in particular produced salmon with very high levels of Murex. After those outliers are removed, summaries for the Murex concentrations in parts per million and the rest of the farm salmon are, so my N value is 150, my mean is 0.0913, and my S value is 0.04595. What does a 95% confidence interval say about Murex? So first I need to find this confidence interval. We're going to do it by hand, but yes, there is a calculator method. Your degrees of freedom, we saw this in the video, is N minus 1. So N is 150. 150 minus 1. What is my degree of freedom? 149. I want to find my T value of 149 degrees of freedom with the confidence interval of 95. This only caps out at 100, so you may want to use this other table here. This is why I put several in today's folder. See, does this go to 140? Nope. Let's use the other one. Okay. Now, where does 98% fit for my one tier test? We're looking at 98, right? No, sorry, 95. 95, as you see, is that 0.025 range. So 0.025, that's for my 95%. I'm looking at 140. So what do I see? 1.977. 1.977. That would be my t-score. My standard error is my S value, 0.0495 over my N, square root of N. Come on now, there we go, 150. And that equals 0.0495 divided by 0.00404. Now, why do I need that? Because my confidence interval is your mean plus or minus the t-score times your standard error. So 0.0913 plus and minus t value was 1.977 times 0.00404. This because plus or minus 0.00799. So what is my confidence interval? 0.0913 minus and then plus. Let me do this same time. So I got 0.0833 and 0.0993. This is parts per million. So there's my 95% confidence. So okay, it is going to be your mean plus or minus the t value you find times your standard error. Go to the next slide. There we go. So I am 95% confident that the mean level of Murex concentration in farm-raised salmon is between this value. So I'm 95% confident I'll find these concentration within my fish in that farm. The rest of the 5% will be outside of that. Now, like I mentioned, you don't have to do it by hand. There is a way to do it by the calculator. So you might want to model as I go along this. So it's stats, test, T interval, right here, number 8. T interval. There's 2 ways you can enter your data. Either you have the stats already, like my mean, my S, and my N, or you have the data. Since I already have the stats, I'm going to click on stats, hit enter. And let's see, what was my mean? 0.0913. My S value, 0.049. N of 150, and a confidence level of 0.95. And calculate. And there we go. Got roughly the same values. Again, it's not going to be exact because the calculator can't go all the way to infinity. It's going to be off by 1,000th of a number or 2. So there's our confidence interval. Same thing we got, right? More or less. Close enough for stats. Now, let's look at that confidence interval in regards to having to put the data in. So find a 90% confidence interval for the following data. Number of hours 20 students slept is 6767, blah, 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 blah. Do you really want to take all this, find the mean, find the S value, find your 5-number summary? No, not when you can just go stats or, yes, edit. So the first thing you want to do, because if you notice, if I go to the test, go to the T interval, if I go to data, hit enter, I need data in my list 1. So we got to put some data in there. So stats, edit, I got some things in there, so let me delete. Go ahead, delete everything you have list 1 and 2. We're only going to need list 1 here, so let me enter. So you're going to put all of your data in your L1, then go to stats, test, T interval, data. My data is in list 1. That's normal. Frequency, just keep that as 1. And what's my confidence interval? 0.9. And the calculator will find your mean, your S, and all that for you. Bam! There it is. Mean of 6.65. S value 1.089. N is 20. And here's my confidence interval. I'm 90% confident that my numbers, my sleep values, will be in between here. 90% confident that if I've grabbed a student, the amount they sleep will be between 6.2 and 7.1. Could you could have somebody like Jocelyn who just sleeps all the time, like at 12, right? You'll be outside, you did the 10%. So yes, 2 ways to find confidence interval. Either you have the stats already, or let the calculator calculate all the stats for you by putting the data.